Hope you have attempted this question before you watch this video. So down here you will see that this context is no longer about an object falling down, or whether this object is going in the horizontal dimension, but it is actually a person sliding down a slope. So this question actually involves some elements of forces, but it's okay because this video is about kinematic and forces. These two chapters usually come together because forces explains why an object moves. Okay, here in figure 2.1, you will see that you have this skier skiing down a slope, and they actually mark out the point the skier reach as time passes. So the first thing you notice is that within the first 2 seconds, A and B, the distance is pretty short. And then within another 2-second interval from 4 seconds to 2 between B and C, the distance traveled is much bigger. So what does this part of the diagram tells you about the speed of this skier? At the first 2 seconds, short distance travel. The next 2 seconds, a much larger distance travel. What can you say about the speed between AB and the speed between BC? Yeah, you can see that because of the shorter distance, actually you can conclude that your skier is actually speeding up. Okay, so when we say speeding up, the technical term in physics is, it will be acceleration, right? So it is accelerating. Yeah, and then of course if you look at C and D, you can notice that the distance covered is even larger. So you can tell that your VT graph will definitely look something like it starts from 0 and then it become bigger, and then it become even bigger, and it become bigger. Okay, so it will keep on climbing in one singular direction. Yeah, there won't be any negative velocity. Yeah, so let's carry on analyzing the question. So here you have a VT graph with 4 points, nothing much. Let's carry on. So down here there's one very important information. It says that between A and C, acceleration is uniform. So in the previous question, if you remember, let's scroll to the first question. We say that the acceleration is given by the gradient of your speed time graph or your velocity time graph, right? So as you can see, this kind of content is being tested repeatedly throughout the years. So that's why it is very crucial that you include this in your notes and then you memorize it. So if you do not know this content, you can't even attempt the question. Yeah. So now we remember that acceleration is given by gradient of a VT graph. You can now figure out something from this statement. So it says acceleration is uniform. Acceleration is the gradient. So you can actually substitute the word acceleration with gradient. So let's do that. So we would then have a clearer picture. So gradient of VT is uniform. Uniform means gradient. Uniform means constant. Yeah. So we know that from A to C, I would expect a constant gradient. Then after that, it says after D, the velocity become constant. Velocity become constant means, does your velocity change? And if that's the case, what is the implication to your acceleration? So when velocity is constant, it means that it doesn't change, right? Velocity doesn't change. And acceleration basically is a measure of the change of velocity per unit time. So in this case, once you see a statement like this, v is constant, basically in your mind, you can convert it to acceleration is not constant. Acceleration is 0. And like what we have said before, acceleration is basically gradient, right? So if acceleration is 0, then gradient of a VT graph will also be 0. Gradient is 0 means that your line is like flat, horizontal. So once you have these two information, then your part A, these 3 marks will be, you can capture it pretty easily, right? So from A to C. So where's A? First dot is A, second dot is B, then C and D, right? So between A to C, gradient is uniform. So meaning that I would have a straight line. Yeah, then it says that after D, the skier is traveling at constant velocity. So therefore here I would expect a flat line like this. So now the trick is I have to connect the line between C and D. So I will just try to connect. Can it be a straight line also? Very unlikely, right? Because when you are traveling at a high speed between C and D, as you can see in this diagram, you are skiing on Earth, right? So there will definitely be air resistance. And when you have a drag force, that means most likely your acceleration cannot be constant because your drag force is changing with speed. So because of that, I would not expect down here to be a straight line, but I would think that it will be a curve. So I will just join the two with a curve like that. And in O level, they are now very particular about when you attain that flat line. So you need to practice a few times to actually draw your curve down like this. Yeah, and that's it. You just finish sketching your VT graph and you score 3 marks. Okay, moving on to the next part, you are asked to actually find the distance between point A and B. And basically, to get the distance, you just need the area under your VT graph. So between A and B, it will be given by this triangular part, because down here it will be a straight line. So you can see this triangle consists of a base of 2 and then a height of 2.2, 2.4. Right, so that is how you get AB. To get BC, then your area under it will become a trapezium. So depending on your level of mathematics, you can calculate it with one formula, or you can break it down into a rectangle and a triangle. Okay, so this part I'm going to skip. After your calculation, you will be able to find out the distance traveled between AB, BC using simple formula for areas, for triangles and trapezium. So you can see that the next part, you are asked to sketch the displacement time graph, and they only give you one additional piece of information, that is the distance between AD. They give you this because you are unable to find it just by geometry, because CD is actually a curve. So if you are smart about exams and smart about doing questions like that, you can actually tell that, oh, if you do not know, like for example here at the very beginning, if you do not know that between CD, is it a straight line or is it a curve, then you can actually use this information given in the question to actually reverse engineer and figure out that, oh, it cannot be a straight line, it has to be a curve. Yeah, so you can always use these kind of tricks to actually make your life easier. So now since I'm asked to do to sketch a displacement time graph, then I think it is easier if you construct a table for yourself. So between 0, displacement will be definitely 0. When it reach A, let's see, oh sorry, when it reach D, that means when time equals to 2. When time equals to 2, then you would have traveled 2.5 meter. That means the distance covered between AB. So this one will be 2.5. And after that, after another 2 seconds, so you reach C, right? So when you reach C, it is not just 8.5 because you are talking about displacement. So when you have reached 4 seconds, the total displacement cover will be 2.5 plus 8.5. So because of that, that's why I asked you to construct a table. Then you will have it will be less likely that you make careless mistakes. So this will be equals to 11. Then after that, when it reached D, which is 8 seconds later, which is at 8 seconds, not 8 seconds later, then you need to use the information given by this, and you know that, oh, okay, your displacement now is 44. So once you have this table, basically it makes your life easier. Not only that, you can now just put dots on your sketch. Sometimes, if you don't do that, you may be intimidated by the question, but by doing such tables, you break down the question into smaller parts and you can then attempt it. So like what I did, I put down the 4 dots, and you can see that these 4 dots kind of like line up nicely like a curve. Yeah, but do not just jump into the conclusion, always check your understanding. This is a displacement time graph. So in a displacement time graph, as we said earlier, whenever we talk about graph, it's always the gradient and the area. So what is the gradient of a displacement time graph? So if you forgot, we have covered that in a previous question. So you scroll up and you will be able to see here. Yeah, gradient of a displacement time graph will give you the velocity. So you need to ask yourself, did we travel at constant velocity? So if you look here, the only part whereby we travel at constant velocity will be here, which is given in the question. Between A and C, there's acceleration, so obviously you won't have constant velocity because you are accelerating. So because of that, you would expect this entire graph from A to D to be a curve, right? So it will be a curve all the way here, from where to where? After D, velocity become constant. So after D, velocity become constant. Okay, you see, I miss it. So I need to draw maybe here constant. Yep. Okay, so I'm drawing it freehand, so I won't be doing it as the line will not be as strict as I want. But for you guys, you need to practice before the exam until you can draw it very smoothly. Make sure that you draw this part down here where I highlighted yellow. This part here, according to the question, after D, your velocity is actually constant, and your velocity when it is on a displacement time graph is given by the gradient. So it is very important that you show this understanding by drawing the line using a ruler. So the boys especially, please use a ruler. Okay, if not, you will be penalized.